1999, the Wachowski and others created lightning in a bottle with The Matrix, aided by heavily influenced Hong Kong cinema fight choreography from legendary action director himself Yuen Wu-ping, gunplay homage from John Woo and Chow Yun-fat, groundbreaking effects and filming techniques created cinematic history. A cultural and ultimately pop influential film that inspired millions then and now. It slowly decomposed with 2 sequels which, although not terrible, were not a patch on the first complete film. This year we saw its reanimated corpse flung around for more money, and why I didn't stick to my guns and not watch the film on streaming when I knew it would be crap is beyond me. I mean, it's absolutely... Anyway, from bad things, good can rise, and it did in the Matrix Awakens demo, a joint collaboration between many of the movie makers here, Epic themselves, Houdini Effects, and even other teams, all pushed to show off the power of next generation technology and specifically Unreal Engine 5, which it did in spectacular fashion. Now that UE5 is officially out in the wild and out of early access, we can now sample just how demanding the future will be for the PC space. Get ready for a bumpy ride. Now I covered the demo when it landed, and there's more details in the specific elements about UE5, what it brings, the problems it's trying to solve, and some it actually creates. Check it out in the links below on my channel and also over on IGN where I went more in depth. Short version here is the engine has a few key elements that not only improve visuals and bring cinematic quality of a few years ago into real-time games, a lot of this helped by the quicksort material and assets of the marketplace that Epic offers, but it also makes it much easier for smaller teams to achieve higher heights. These break down to the main aspects below. Nanite virtualized geometry, Lumen real-time global illumination, virtualized shadow maps and ray trace shadows, procedural world and AI generation and control, Houdini integration and plugin, which cannot be under-egged just how much this demo has been built around Houdini, and the meta-human character creation. Now these are the headline areas. There are more benefits and improvements to the engine and changes, but I can't go into those in this. I've got to pick my battles for videos. Much of the new engine upgrades focus around the SSD, memory upgrades and HUMA structure of current generation consoles. That's heterogeneous memory configuration. The Series X and more specifically the PlayStation 5 have significantly moved the game on here, and as I discussed back before the current generation began, sometime in 2018, the focus on an SSD was only part of the equation. The Series X and S offloads a good amount of the decompression and memory allocation of data from the drive into RAM, and then it is used by the CPU or GPU as required. Always has been and always will be a big part of data usage, not just games. It still has an overhead though that hits the CPU beyond the decompression blocks within the APU, but it significantly aids the performance target for Epic as a baseline. The PlayStation 5 goes further still, where all of this is now offloaded from the CPU and handled by dedicated decompression and allocation blocks with a greater channel allocation. This obviously doesn't affect the GPU either, meaning it can process more data faster with no CPU or GPU costs compared to PC, and even less than Series X and Series S. UE5 embraces this, meaning that the SSD can be used as a virtualized data block beyond just textures and geometry in the Nanite system. They're all reliant on it, which I tested this before when I did the Valley of the Ancients demo, which you can run it on a basic hard drive, but the latency cost, the delay time, the seek time, all of that has too big an impact. It's not just about the bandwidth, the throughput of the drive. Again, I'm going to skip any detail on that. Go back and look at the videos to see where I discussed that in more detail. Fundamentally, this whole process has been designed around those meshes being delivered and dynamically cooled and displayed on a frame-by-frame basis. As you can see here from the cluster view within the engine itself, constantly shifting and changing within the object silhouette. The engine is constantly reconfiguring cars, buildings, streets and more as the camera moves to maximize the relevant GPU and CPU budget by virtualizing the data, similar to how textures have been for the past 7 or so years. These are calculated into these cluster LODs for each object and then constantly calculating the best compromise of detail versus geometry to render and distance from camera. It's a very data-driven and dynamic approach the entire engine is geared towards, and it relies heavily on that close knitting of the SSD, the memory subsystem, and those quick pools of RAM, including those virtualized cache elements, and the caches on the GPU and CPU. All of that has a huge cost to bear here. But why is all this relevant for the PC comparison, you may ask? Well, let me explain. I'm repeating myself a little from older videos, but the PC's biggest strength is also its biggest weakness. Being able to modularize your PC enables you to maximize how powerful, cost-effective, or focused it is. But it also means that developers cannot target one spec and thus have to target a baseline across them all. This equates to less focused and specific methods as per console, a reliance on IDH driver support, the quality of said driver, and the inherent weaknesses of the PC design. More predominantly, the cost of Windows itself, driver variants and costs, split pools of RAM, a relatively slow PCIe bus compared to VRAM speeds at least. 3.0 16 times is only 16 gigabytes per second, and 4.0 doubles this to 32, which means a variety of configurations, APIs and performance levels from PC to PC, and this doesn't even take into account the quality of DX12U or Vulkan or all the other complications around which API renderer you use. Brute force is the only way, and now, more so than the last 5 years, this is harder to achieve and comes at a very high premium. Equal GPU performance to PlayStation 5 and Xbox Series X, for example, is likely 2 times the price at best, which is for the GPU alone, which is useless on its own. The same for the CPU, where you need far more than what's available in these consoles, which are already pretty capable Zen 2 CPUs. DX12U or Vulkan is required as a rendering API to support ray tracing alone, aside some unsupported options and hacks, and the direct storage API within DX12U is still a work in progress, with currently only CPU being used to decompress and then allocate data into active use by the PC, and this all comes at a far higher cost on PC, borne out within this compiled demo. Again, it's not about the data throughput. These have a fixed cost like many things on a frame by frame basis. But first we need to get to the point of actually having a demo to test. So downloading the city sample from Epic, I discovered that the latest UE5 engine has been, unsurprisingly, significantly updated, and I couldn't compile it with that. So I updated to the latest one, messed around a little bit, and then built a configuration here. The baseline requirements for the demo are actually in that when you load it up and actually before you load a map. It needs an RTX 2080, 64 gigabytes of RAM. It's an obvious development machine, and in fact trying to load the full map into the editor on a 32 gigabyte machine just crashed because insufficient RAM and VRAM. Not a surprise really, but does demonstrate the minimum specs here. They're not inaccurate and totally expected as you are developing this in the UE5 editor, so that's the point. It's far more expensive with all the overhead around that development environment to test it within. The smaller city map can actually load into 32 gigabytes and it's playable. It runs pretty close to the actual compiled demo. It does stutter, but luckily we can at least compile the full map into a fully fledged release build and deploy this into a single XE. We allocate a folder, we leave it for approximately an hour, and we have a full XE to use on any PC we want. I did play around with some of the configuration settings in Unreal Engine 5, but I'm not going to delve too deep in those at the moment. That's for later videos. I'm still working my way around some of the functions and features here. I will touch on a few though throughout the video.
The hell are you doing back there?
Sorry, I was told this is a sim preparing me to fight the system.
Right on. You know about this?
Yeah, it's all supposed to be a little unreal.
Now, as the spec states, we only can use an RTX or a modern RDNA 2 card to maximize this, i.e. the dedicated hardware ray tracing options. So first up is my RTX 2070, an overclocked GPU at 9.4 teraflop machine, and it's got a pretty decent CPU, offering performance in excess of what we can get on the consoles from a frequency and core perspective at least. 2700X at 3.8 or 4 gigahertz, 8 cores, 16 threads. It's pretty fast, and certainly from a frequency perspective, it's faster than what we've got on the consoles. And it offers 32 gigabytes of 2.6 gigahertz. That's around 34.1 gigabytes bandwidth. It's a decent PC and well above 90% in the Steam survey of machines. Performance is way below what I'm sure many of you have expected or hoped for though, and I did warn you around 3 to 4 years ago. Even at 1080p walking around, we are hovering in the low 20s. Once in a vehicle and driving, this drops down to 10 to 14 FPS, which is unplayable and is on average 50% compared to the PlayStation 5. But why? The GPU, as you can see, remains fully locked around 2025 to 2040 megahertz, but utilization is only 70 to 85% occupied. CPU is in far greater demand, with it often close to maximizing multiple cores and hitting 50% plus total usage. Again though, it's not always maxing the CPU or GPU out frame to frame, and it still has headroom to spare, meaning resolution could go up approximately 25% with no visible performance cost. And this is proved by dropping the resolution of the machine to around, well, 540p. Get in the menu settings, you can drop it down to half and use that TSR solution to bring it back up to 1080p. So it's now rendering at half the resolution, and we see identical performance, give or take. Reduce GPU utilization though, as expected, because it's just hanging around waiting for work. And again, if you bump this up 20% over 1080p, you'd still see identical performance, but just better utilization. Why though? Well, I suspect much of this is the data-heavy process the engine is now focused on. From virtualized geometry along with textures, BVH-like data for that hardware-accelerated Lumen solution used for real-time light bounce, reflections, shadows, and radiosity. These are all stored within a Lumen canvas and then looked up for each surface of an object. And you can actually visualize these with cards, that radiosity and such within the engine itself. But fundamentally, what we've got here is an identical export at levels 3 for most things, as are perfectly matched to what we see on the PS5 and the Series X of the same demo. So I'm going to center around that as a conversation and certainly a comparison piece here. The one thing we can discuss is that TSR, temporal super resolution, that's being used here in Unreal Engine 4. It's very impressive, even from much lower bases. Maybe not quite DLSS and FSR 2.0 or XeSS levels, potentially, but here as you can see zoomed in at 1080p versus 540p, so half the resolution. On a 1080p screen, it's very, very good, and it does look impressive. There's certainly issues with the ray tracing elements, the denoising filter, and flicking and popping, but that even happens on the console versions, which are predominantly 1080p with a TSR back to a high resolution. Looks like 1440p. Again though, running this at slightly above those levels, which I think is perfectly possible, I still think there's a level of underutilization on the GPUs for consoles as well, it really would look very impressive, and certainly highlights again why these solutions are much better than just trying to run native 4K, which you can do on the RX 6800, but obviously that means that you're utilizing the GPU better, you're not getting better performance. So as it stands, you're not GPU bound here on the consoles, and certainly not on the PC. But this isn't about just GPU. I'm not going to go into too much depth on this, but I did discuss this around the whole construction of caches and memory and all of that a couple of years ago with the Infinity cache. And it will be interesting to see how different PC formats scale this information. But fundamentally, this is a data-driven engine, and that means you're going to see huge impacts, as we're seeing here, where data is stale. It's not in the queues, it's not ready, and therefore the prefetches, the compilers, all of those things within the SDK of consoles are vastly different and more efficient. And then specifically around the PlayStation 5, those I/O coherency engine elements, the cache scrubbers, and all of that work offloaded in the centralized I/O die means that the CPU and GPU can just get on with doing the work and not waste time waiting for data. All of this isn't possible on PCs, and you can't focus it at a level that makes all of that quite predictable. And because you've got ray tracing here, you've got dynamic nanite technology, you've got AI, you've got path tracing, very data-driven engine by and large, it means that there's a very randomized, non-constructed sets of data at all times as you're flying and driving around the city, and that means you get the very worst case scenarios. And that's why we're seeing such a huge delta. It's not just CPU versus GPU like many people boil it down to. That's just incorrect, and it misses the complexity of what is going on here. And in all engines, let's be honest, this is not just an Unreal Engine 5 issue. The CPU and associated driver stroke API cost will be much lower than on PC. Memory is significantly simplified due to the single pools on console, negating any shared pools, memcopy, and obviously they can maximize the cache allocation, which isn't identical to PC either. And you've got a fixed function, effectively, GPU and CPU to work with. They're both Zen 2. They've both got a dedicated APU. They've both got a fixed block of VRAM that the CPU and GPU can access. So you can see where all of this becomes a very simplified process, and a lot of this is where all the cost and overhead comes back onto PC, and why we're seeing such poor performance, or at least part of the reason why. You see, the PlayStation 5 and largely the Series S consoles and X, but it does still have a software segmentation of memory in place, offer huge benefits over the PC due to this memory utilization, specifically something as data rich and intense as UE5. One of the biggest boosts is the complete offloading of that decompression, copy, register and allocating the data from the SSD, having no cost on the CPU and GPU for the PS5 and a reduced cost over PC on the Series consoles. This means that we're seeing better utilization on the consoles, which means that for sheer performance, even on an AMD RX 6800 GPU, a 16 teraflop GPU mind, with 32 gigabytes of RAM, is still falling 35 to 45% below the performance levels of the PlayStation 5 just from walking around the city. This is also not even taking into account the shader caching and sheer wealth of complexity and cost this adds to something like UE5, as draw call efficiency can be affected, shader complexity can grow into the millions due to the complex multi-layered material system being used here, Uber shaders and all those permutations effectively to negate the branching shader code, which they're not really designed to do, and it's not how you write the code in HSL. It's very atypical of what you would normally write in CPU code and C++. All of that is created to try and generate single files, single flavors basically of all these combinations, making for an excessive delay as they have to generate them at runtime when needed, and this then improves the second, third time as the driver cached version is then used. Pre-building these up front, such as we see on Horizon Zero Dawn on PC, can significantly reduce this, but it is a common problem on PC and only gotten worse with DX12, as much of this is now passed over to the developer, and we are seeing that here in UE5. Again though, due to the complexity of PBR based materials, additional shader complexity, all of this is going to get worse, and it can affect consoles. We saw similar things in Elden Ring as well. It wasn't the only issue there, like I stressed at the time of my review, but again, it is a problem that can be a massive one, certainly on PC. It never gets fully resolved, but it does help by compiling these and reducing those gigantic spikes we can see on both machines, sometimes into the 1000 millisecond plus range. The chaos physics and mesh deformation can still cause other issues here as well, as it does on consoles. Bear in mind, the console version is also not very well optimized, as I covered then. And these are all worse than they were on the console, with longer hangs, worse issues, the physics playing up, cars flipping, delayed reactions to impacts, all the meshes being swapped out to standard skin geometry, as Nanite cannot support these. Currently, one of the limitations I mentioned earlier. Does all this mean then that UE5 is going to be rubbish on PC then? Well, no. This is a perfect example of what kind of work needs to happen on PC to maximize the potential and tailor it for a significantly different architecture and fundamentally audience. You've got two vendors at the moment in terms of GPU. You're going to have three very soon with Intel coming into the mix. One area we will see them enable is a greater allocation of that VRAM pool, I'm pretty sure. Loading more data into this and then swapping out slightly earlier to hide the latency cost and raise that GPU utilization is an obvious one. And you can actually do some of these things in the demo engine itself. It doesn't go above 8 gigabytes of RAM on the actual VRAM allocation so far, but you could have just as easily reduced that SSD and VRAM delta from consoles by filling up more VRAM, such as my 16 gigabyte RX 6800 here. That would really help by just loading more assets and data into there and then not having to stream it as often, which again is kind of circumventing the point of it. But when you've got the additional RAM, that's the one benefit. Again, going back to my main point of modularization, where PCs have to brute force it. So you're going to see a bigger demand on VRAM, just like we did last generation when I told everyone before it started, do not buy 2 gig cards. 8 gigabyte cards are not going to cut it this generation. Potentially 12 aren't. You know, you're looking at 16 as a minimum, potentially more. Those 32 gigabytes of system RAM, that could be filled more to enable that PCIe bandwidth to be maximized and again close that gap we are seeing here. My limited time with the demo so far means I can't tweak as much as I want. I've only had a day or two to play with this, and there are options here to get better performance. But fundamentally, what the PC is limited by is the utilization reliance on CPU and where that data is in that process, meaning the spikes on the CPU will be aggressively high, and it does scale well with cores and it does scale well with frequency. In fact, it actually scales best with both, as you can see here. Cutting it right down on my my 2700X CPU, cutting it down to just 4 cores, so 8 threads, but running it at 4 gigahertz. we see around 20 FPS performance here. But literally leaving it at 4 gigahertz and turning those other 4 cores on to now doubling the threads, we can see that I gain around 30% performance benefit from that, over 25% give or take. That's a huge performance from the fact that it is multi-threading as much as possible. And I see a lot of people saying just multi-thread it. You've never written code, especially code as complicated as this, which is beyond me as well. I'm not a GPU programmer, like I say. But writing code that's multi-threaded and data reliant like this just creates data race issues. And that becomes very, very hard. So the fact they are utilizing threads so well here with the ray tracing functionality, the Lumen reflections, the Nanite geometry, all of that is being threaded as much as possible. But you're always going to be as slow or as fast as your slowest point, and that is always going to be data, which means what you're having here is CPU spikes up and down as it's having to ram in work as quickly as possible whilst it wasted however many cycles I'm sure are being wasted here, waiting for the cache being thrashed where the data is not there and it's missing caches and then it's got to come back again and wait for the data to be continued. All of that is having an obvious effect on performance, and that means when you stack these two up against the PlayStation 5, and even, take the RX 6800 here, but you've just seen footage against the RX 2070. It's more than double performance on the PS5 at the same settings, the same resolution. And it's slightly better on the RX 6800, absolutely. But the CPU's only got similar cores. So remember, the PS5's only got around 6.5 cores available. So this is fundamentally what it's running with, 6 cores, 12 threads, give or take. And that's what you're seeing here, and it's still behind it. And it's a faster clock, over 4 gigahertz here. So you can definitely see where there's a lot of options for optimization here to improve. Doubling the frequency doesn't just naturally double the performance. It's not fully CPU bound. It does help, but it's still being limited by other factors I've just mentioned. It's not just CPU. And again, I do get frustrated. I'm sure many developers do when people just talk about things. It's a GPU, it's a CPU. If only you could optimize that easily. There's only 2 things to worry about, guys. Fix one of those 2 and we're sorted. Let's crack on. It's very complicated, and I'm trying to stress, I don't know all the answers. I don't know what's going on here. I don't have all the time to dive into this, and even if I did, I probably wouldn't be able to have all the answers. But fundamentally, there's a lot more here that needs to be done, both on consoles and on PC. So don't point the finger and say this means that UE5 is going to be a 30 FPS engine. That's just silly, because you can turn all these features off and reduce them in the settings, and then you can get up to 60 FPS and above, even on an RTX 2070. So the choice of an engine to be whatever frame rate it needs to be is up to the developer. It's got nothing to do with the engine at all. Not every game is going to target this level of integration. And there's a lot of data-driven automation here to help the workflow. That's the point of the demo. It's not really for us, the audience, to look at. It's to get developers all giddy and excited about how easy it is to make these grand worlds without having to spend months and years of your life creating everything by hand and then realizing you've made a mistake. So that's the point of this. That's the point of UE5 at the moment. Doesn't mean that everyone's going to use it for that, and doesn't mean it won't improve at all times. The more people are digging into this, just like I discussed on my database video about CD Projekt Red and why they went to UE5, is all around the fact that the more people doing the same thing, the more benefits you get from everybody combining to the same target and fixing things. So things will be fixed, I'm sure. A good deal of work is still required in the demo. I'm not going to lie. It's not going to happen overnight. And as discussed in my previous console version, this is not a heavily optimized demo. And it's a demonstration of the future that we're moving into, and a sign of the challenges and changes that need to come to make sure this becomes a usable function set for many developers. What we should expect from UE5. But it's a very interesting demonstration nonetheless. Right now, teams have been using UE5 for a year or so, but as of this month, the wider development community can now dig into it in a Showtime-ready release, and that means we will take time for the teams to understand, adapt, and change to the new solutions and methods it offers. Being a multi-platform third-party engine, the overhead is much higher, which has always been the case for UE5, UE4, UE3, and it'll be very interesting to see just what Sony first-party teams deliver this generation, along with idTech, Northlight, and other engine providers will produce alongside this growing number of teams jumping to UE5 this gen. Those parallel development paths will be very interesting to see what comes to the forefront in terms of solutions for this current generation. CD Projekt and now Crystal Dynamics have all jumped over to UE5 as well, and Nanite is a core function of UE5. Lumen, as a software and hardware accelerated mode, offers a great deal of configuration choices using SDF to deliver GI and not even use hardware ray tracing as well. So Lumen has options here to be used in a great many ways, and all in all, using GI bounce, reflections, and those dynamic elements of ray tracing, as I've always said, is the biggest benefit to visual quality because it improves the consistency, the coherency of the world, and the quality of materials, which is where things start to look more film-like. Overall, it should be a very enlightening time for game development ahead of us, and I'll be here to take you on that journey as we go through it. It's going to get bumpy for the rest of 2022, I'm sure. And we've reached the end of another video. Hopefully you found that encouraging in terms of the future of UE5 and informative and technically deep enough to give you an explanation and hopefully explain and show why things happen the way they do. And it's not always as simple as you may think. Hopefully this was good enough. It wasn't as tight as well constructed, but I need to make the time to get these videos out when they're pertinent and not wait too long trying to edit them down in the space that I have. Remember, I am completely full-time on this. It's a part-time thing. But you can help by hitting my Patreon, which gets you access to some exclusive content on there, or at least early access to stuff as well. Q&A on my database video, which should be up tomorrow, and obviously other elements that support the channel. Obviously, you can also like, subscribe, and leave a comment down below. All of that really helps the channel, and I really, really appreciate each and every one of you that does. But for now, I'm out and off into the sunset. I'll catch you on the next one.